Assalamualaikum and good afternoon. Okay. Today kita akan masuk on chapter 6, structural steel column design. Last week kita dah covered everything in chapter 5, structural beam, steel beam design. Recorded video on steel beam yang saya buat tutorial tu, saya akan upload hopefully today lah, sebab saya tak habis lagi edit. Okay, without further ado, let's just dive in to this chapter. Okay, design of compression members. So basically when we referring to BS 5950 for steel design, okay, column kita akan kata dia adalah compression members. Even dalam beam sekalipun everything that kita akan refer to mesti pada compression member sebab column dia adalah compression member, because for example this is steel column. Okay, the force that acting on it may come from above lah. Above ni datang dari mana? Probably if it's only one story, so dia datang daripada beam, roof beam here. So you have beam here, then dia akan transfer load to column. So basically this is compression load, and a very minor tension load, tensile load, tensile stress. Sebab normally tensile stress ni datang daripada, for example like wind, okay, other factors and tensile load ni dia not so much lah. Okay, the compressive effective length, the compressive strength of strut is primarily related to their slenderness ratio. So if you see here, this is lambda, then we call it slenderness ratio. Slenderness ratio ni is a ratio of kekurusan dan ketinggian lah, senang cerita equal to effective length divided by R, which is the radius of gyration. So this radius of gyration adalah one of characteristic of steel section that you can refer dari table. So you akan nampak dia ada Rx and Ry. So different axes have a different radius of gyration. And effective length, this one is actually based on this. Okay, if you look at this table, so you will see table 3 nominal effective length LE for a strut. Okay, effective length. So here you nampak macam ada factor dekat depan darab dengan length. Okay, factor ni 0.7, 0.85 and so on. And how we get this factor, it always depends on the end support of the column. Macam mana end support dia, whether it fixed, whether it partially restrained and so on. Depends on it, whether it's spin and such lah. Okay, kita tengok first one. So here, kalau dekat sini, okay, this is the first condition lah maksudnya, and this is the other one. Okay, yang ni okay, 1, 2, 3, 4. Okay, this type of column is brace. Kita akan angkat dia brace and unswayed ataupun unswayed lah. And this tree, another tree is unbraced and sway. So maksudnya bila dia tak di brace, dia boleh sway lah, maksudnya ke kanan, ke kiri, ke kanan, ke kiri, macam tu lah maksud dia. And also if you look at here, kat sini ada 1, 2, 3, 4, 5, 6, 7. So we have like 7 conditions. So 7 condition, if you nak lebih faham how actually it looks like, you can refer here. Okay, kalau you nampak dekat sini absentnya, nampak tak, dia macam sengit lah. Mana ada kita letak kolom sengit macam ni, tak ada. But this is for calculation purpose only. Okay, maksudnya if let's say you have this kind of condition, so you assume that dari segi calculationnya, dia akan jadi macam ni. Okay, maksudnya effective length dia mungkin akan makin panjang. Macam tu So bila makin panjang, okay, contohnya bila you dapat effective length makin panjang, makin tinggi. Okay, contohnya macam kalau kat sini tengok ada number like 1.2L, 1.5L. Kalau you darab L, contohnya L 4 meter. So you dapat darab 1.2, dia akan lagi makin panjang, which is become 4.8 kan. So 4.8 is actually longer than its actual length. That's big. Why this happen? Because of dia punya end support dia. Mungkin end support dia because kalau you tengok dekat sini dia dalam gang unbrace ataupun gang sway. So gang unbrace and sway ni is not dia tak fix, maksudnya dia tak ada bracing meaning dia sangat free, dia sangat tidak kukuh lah, senang cakap bukanlah nak kata kukuh, sangat tidak stiff lah macam tu Jadi bila keadaan macam tu, kita akan anggap effective length tu tinggi. So maksudnya kita kena provide perhaps bigger size of column, so that at least dia kurang sway ataupun dia lebih kukuh sikit lah daripada kalau you dapat effective length yang lower, maybe you can provide smaller size of beam. Sebab effective length kan normally kalau kita kira, kalau kita design something, kita nampak lah, if let's say column tu makin tinggi, obviously dia makin kita kena provide bigger size of column, betul? Kalau makin tinggi. Kalau column tu rendah, mungkin kita boleh provide lower size of column, sebab kita nak kan dia punya gravity so betul-betul dekat bila dia makin besar dia makin seimbang kan. Okay, kalau you tahu, you perasan okay, so bila column tu tinggi kita provide bigger size of column. Kalau column tu rendah, normally kita akan provide lower. So bila kita dah macam, this is for calculation saja tau. Kalau you nampak effective length, this effective length it doesn't happen in real life. Mana ada orang letak kolom tu sengit gitu, tak ada. Okay, but it just this is for calculation purpose, because kita tengok, kita compare kan sebenarnya dengan pin support. So kalau you tengok yang the first, yang 1.0 ni sebenarnya adalah pin support. Okay, ataupun roller so dia boleh berpusing-pusing. So sebenarnya kita compare dengan this one. Okay, kalau pin support kita kata 1L, maksudnya kalau 4 meter times 1 dia become 4 meter. Tapi kalau you compare dengan okay, contohnya bila yang ke atas ni dia akan makin makin dia punya end support dia lebih kukuh contohnya. So you nampak dia makin number of factor kat depan ni will go lower. Okay, but bila you tengok ke bawah ni makin tinggi. So bila you compare dengan pin support, you will see this thing lah. Maksudnya depends pada dia punya end support dia macam mana. I hope you understand on that. So I akan explain one by one on this part. Okay, so kita tengok one by one firstly, kalau kita I akan cover on the brace and unswayed ni dulu. 1, 2, 3, 4. Effectively help in position at both end. So apa maksud dia? If you look at gambar ni you nampak position dia ke atas ni je, atas bawah. Okay, so satu garis satu tegak lah, tegak. Okay, so 1, 2, 3, 4. So effectively held in position at both end. Itu maksud dia. Okay, first kita tengok yang number 1, restrain in direction at both end. So 0.7 times length. So restrain in direction at both end. Okay, position dia memang fix, tapi dia also fix dari segi position. So ini adalah fix end lah. Okay, so kalau you tengok dekat belakang ni ada juga illustration lain yang actually this is how it looks like lah. So this is number 1. So kalau you nampak this, inilah maksud dia bracing tu, bracing. Okay, ini bracing untuk dia bagi dia effectively held in direction. Okay, so dia akan effectively held in position, so dia akan fix macam ni lah. So bracing ni menyebabkan dia effectively held in position kat belah atas. Okay, and ini adalah effectively held in direction. So kalau kat bawah ni effectively held in direction, effectively held in direction and position. Okay, jadi ini adalah number 1. Okay, and then number 2, effective. Okay, yang ni I tak nak cerita lah yang effectively held in position semua ni, because kita dah tahu kita tengok 1, 2, 3, 4 ni. Okay, partially restrained in direction at both ends. So 0.8 L. Partially restrained in direction. So you nampak partially restrained, so dia masih boleh ada direction, as in mungkin macam hinge ke like that. So dia boleh moving macam tu, or roller. So dia boleh moving dia boleh berpusing lah. Okay, dia macam boleh berpusing. Okay, and then number 3, restrain in direction at one end. Okay, restrain in direction at one end 0.85 L. So you nampak kat bawah ni, okay, dia memang restrain in direction at one end, maksudnya end kat bawah memang dua-dua ni effectively held in position, and one end restrain direction and the other end tak restrain in direction, dia masih lagi boleh berpusing. Okay, so kalau you tengok okay, dekat belakang ni ada juga. Okay, this is number 3. Okay, this is how it looks like in the actual kind of column lah. Okay, so you nampak dia ada bracing, sebab ini adalah brace type ataupun unsway, so dia mesti ada bracing. Okay, dia fix in direction and position dekat bawah. However, dekat atas ni dia memang fix in position because ada bracing ni yang menyebabkan dia fix in position, but dia bebas bergerak dekat atas, as in the direction can be berpusing-pusing sikit lah kat atas tu. Bukanlah maksudnya you akan nampak dia berpusing macam like berpusing-pusing, as in berputar-putar macam tu, bukan. But it just like a minor movement, that kind of thing they allow. Okay, they allow some flexibility there. Okay, number 4, not restrained in direction at either end. So 1.0 L. So inilah yang saya cakap pin support ataupun roller kalau you nampak dia allow some movement in direction so dia lebih flexible lah. Okay, but it just the position masih lagi atas dan bawah fix, atas dan bawah masih lagi restrain. Okay, hopefully you understand on that. So kita tengok yang 5, 6, 7 which is unbrace ataupun sway. Okay, ada 3 here. Okay, kita tengok one end. Okay, kalau kat sini dia terangkan dari segi end, kalau kat sini dia terangkan, kalau this one dia cakap pasal position kan. Okay, and then kat sini dia cakap pasal direction semua. Okay, but here dia cakap pasal one end, maksudnya end yang dekat bawah sekali, bawah ni, ni one end. Okay, and the other end adalah yang this one. Okay, belah atas dia. So one end effectively held in position and restrained in direction. Okay, effectively held in position and restrained in direction. Bermaksud dia, maksudnya position and direction restrain. So kalau nampak 1, 2, 3, 5, 6, 7 ni semua adalah fix dekat bawah ni. Semua restrain in direction and restrain in position. However, the other end tu yang lain-lain. First one is the other end not held in position. So position dekat atas tu bukan tegak. Okay, kalau you nampak kat sini semua dia tak tegak macam ni. Okay, so itu maksud dia position not held, but direction yang lain, which is effectively restrained in direction. So effectively restrained in direction, number 5. So you nampak ini adalah fix. Okay, bila restrain in direction, dia fix macam ni okay. So kalau you nak tengok dari segi visually lah how it looks like, so this is the one inilah dia, this is number, what is it, number 5 okay. Yang ni saya lupa tadi nak cakap ni number 4 okay. Number 4 tadi yang pin support yang for brace dengan unsway tadi, this is number 4. So number 5 kalau nampak dia memang unbrace okay. 5 dia unbrace, effectively held in position and direction dekat one end, and at the both side it says that it is effectively held in direction tapi not in position. Position dia tak sebab dia tak ada bracing kan, jadi dia macam boleh bergerak ke kanan ke kiri dia tak ada bracing yang menyebabkan dia akan tegak aja macam tu okay. But dia punya movement tu not really lah macam you nampak dia bergegar-gegar macam tu, tak. It just dia allow some swaying ataupun flexibility sikit kat situ and then the 6 here partially okay, one end ni memang dah effectively held in position restrain direction okay, and the position also not held in another end, and at that end also it is partially restrained in direction 1.5 okay. So this is how it looks like, so they allow some what we call it rotation rotation, yes, rotation. So dia bergerak, dia boleh berpusing sikit lah dekat situ okay. Tak ada illustration yang kat belakang ni, ada some je yang ada illustration like this so susah sikit saya nak cerita. And then yang last kali here, not restrained in direction, so dia not held in position and also not restrained in direction at one end, so maksud dia apa, free end lah, free okay, like this okay. Tapi maksudnya macam ni bukanlah tak ada sambungan, macam mana pula dia mestilah ada beam above, right? So this is how it looks like okay. So dia not really, dia kalau you nampak kat sini beza dia bukan macam kalau compare dengan number 5 kan, you nampak dia like bracing, like this is like fixed, so this one is like sambungan saja like that, so dia very very flexible so this is number 7, the last one okay. So kita dah tengok beberapa condition, 7 condition yang very common so we can proceed. Sama juga lagi column materials, the properties, this one hopefully we masih ingat, so I tak nak explain. Ini macam dalam steel beam okay. And also we have this one yang column section here, you can always sebab sebenarnya dia sama saja, maksudnya apa yang dia label dekat sini, contohnya the capital D which is the total depth and the D which is the height of the web okay, ini semua sama okay. Jadi kita just boleh refer saja pada gambar ni so that kita boleh refer pada table inilah, table properties kita. Mana table properties? Okay, tak ada. Okay, nanti saya tunjuk table properties tu. Okay, so inilah dia cross section of column. So cross section dimension properties to universal. Column ni ada this one sajalah, satu table saja. Okay. So kalau you nampak dekat sini, column ni number like 305, 254, 323 sama je lah, like serial size. Maksudnya dia group together under one family lah. Maksudnya size or dimension dia lebih kurang sama. Okay. However here, kalau you nampak 305 dan 305, dia lebih kita panggil dia H section dan kita tak panggil dia I section sebab H kan dia lebih macam ini kan, so panjang ni dengan panjang ini lebih kurang sama lah. So 305, 205, 254, 254. Okay, so H section. Oh, that's for column. Okay, and other properties sama. So macam if let's say you nak tengok tadi yang I ada bagi tahu pasal radius of gyration depends on the section. So ini dia X and Y axis. So for column kita akan check dua-dua axis X dengan axis Y. Why? Sebab column tak macam beam. Beam kita biarkan dia, kita letak dia tegak macam ni. Kita takkan letak dia baring macam ni. Okay, so force tu coming from above macam ni, kena dekat daripada slab, transferred to beam. So dia macam ni lah. Okay, daripada atas. However, for column, since column ni dia tegak like this one. Okay, so if force transferred from here, so kalau arah sini adalah X, kalau sini adalah Y. Okay, so both of it affected. Tak macam this one. Sebab this one dia affect pada arah X saja because you letak beam tegak macam ni. Tegak macam ni. Tapi for column, kita letak dia as a vertical. Okay, this one is horizontal and this one is vertical. So when it's a vertical member, force yang coming from above, so arah X and arah Y both will be affected. Okay, so that's the reason. Okay, so I'm not going to explain about this universal column sebab mostly properties sudah tengok masa beam punya, so dia sama saja properties given here, and label dia pun sama je lah, where is D, where is T and where is B semua. Okay, and another thing that you kena check okay, satu kita pun kena check juga classification. So that's why tadi I ada tunjuk juga this one, sebab lepas kita pilih which section that we're going to use, we still need to check for the classification. Okay, so B over T and D over T ni lah. So kita still check for dia punya classification. The classification sama je, and ada yang berubah sikit lah sebab ada yang kita tengok pada compression, but that one kita akan tengok masa kita calculate later on. Okay, here this one is actually sebab kita nak kira for compressive strength PC so different daripada the way we calculate for beam. Sebab beam kita tengok on the shear force, shear force and moment. Okay, but here kita tengok the compressive strength which is PC, and to check the PC of the section that kita kira tu, okay, kita kena tengok on strut table section, this one so strut table section ni abaikanlah 27 ni, so 27 ni is actually nama table tu je, tapi ada, okay, kalau you tengok dekat sini dia ada A, okay, kalau tengok curve A, so sambungan je ni sebenarnya. Alamak, ini saya salah letak lah, never mind, kejap contohnya, okay, like ini pun sama, what happened to you? Okay, contohnya like this one, sambungan saja. Nanti saya betulkan balik yang tu. Okay, 15, 20, 108, 110. Dia sambung saja. Okay, so ini curve C. So every curve dia ada. So you akan ada banyak table Curve D. So 108, 110. So this one saya akan betulkan balik. Should be 108. So kat sini akan start 110 lah. But I letak salah. Curve B. Okay. Curve A. So ada curve A, curve B, curve C and curve D. So mana so tak semua table tu you akan refer, because kita akan refer pada which type of section yang you akan kira. So you akan tengok dari segi thickness dia yang mana satu. Okay, so kita akan tengok on this thickness. Okay, so depends by thickness. So T kat sini is a, oh man, it's a T, this one ataupun T ni lah, because we have web and we have flange. Okay, so T yang ni T web, T yang ni T flange. Okay, so sebenarnya ini being extracted daripada BS. Dalam BS rupa dia macam ni lah. We have like so many others section types. Okay, bukannya just H section je yang ada kat dunia ni. We have like hollow section, I section, welded ataupun roll, and then we have welded box, row angle, channel, T section, blah blah blah. Okay, so there are so many other section, tapi kita just cover on H section sahaja. Roll H section. Okay, kat sini kalau tengok table B, C, C, D ni, so kalau X is obviously kalau katakan kita tengah kira untuk XX. So if let's say the thickness tadi is less than is less than 40 or equal to 40, you akan pakai table B. Table B ni yang mana? Table yang ni lah, compressive strength ni. Okay, so you akan refer to the slenderness ratio and refer to the PY. PY dia 265 ke, 275 ke, 255 ke, 245 ke. Okay, so refer to this and you're going to get some values here lah. Berapa value. So you're going to use that for PC. Okay, which is the compressive strength of the section section yang you tengah calculate tu. So you akan tengok curve P or you akan tengok curve C. Depends pada axis mana and section apa you tengok and the thickness dia berapa, baru you refer to this table So you're going to get the PC. Okay, untuk kira lah. Okay, so you dah dapat the compressive strength. Untuk apa compressive strength? Because kita nak masukkan dekat dalam this table. So for class 1 plastic, class 2 compact, class 3 semi compact cross section, so kita just make sure that kita punya column tu bukan slender type. Okay, kalau slender type formula dia jadi lain. Contohnya formula dia kat sini lah. That was for slender, tak nampak sangat Tapi kita just make sure je. So kita cover up until dia bukan slender. Okay, sama ada dia plastik ke, doesn't matter dia plastik ke, dia compact ke semi compact. So we just can use this formula. PC equal to AGPC. So PC kat sini adalah compressive strength tadi. This PC referring to compressive strength tadi. However, PC yang besar ni, so ada small PC, PC yang kecil adalah compressive strength. PC yang besar ni adalah compression resistance. So how we going to calculate? You ambil je compressive strength tadi. Compression strength tadi you darab dengan area, gross area of the section, and then you akan dapat the PC. So you dapatlah berapa resistance dia. So you akan compare dengan the load yang acting on the column, which one is bigger. So yang mana lebih besar? Kalau resistance ni lebih besar, meaning that the column can support the load. Okay, so itu saja on this lecture. On the calculation side kita akan buat next week. Okay, good luck for your final test tomorrow. Have a nice day everyone.